In question 6, the region area is bounded by y equal to tangent square x, and you look at x from 0 to pi over 2, not including pi over 2, the y-axis and y equal to 3. So the region R is bounded by y equal to tangent square x, y-axis and y equal to 3. And you are supposed to find the area of the region area. First, you must have some idea how the graph of y equal to tangent square x looks like. You actually look at the red curve here. It's actually increasing, no turning point. And to understand this, you can look at tangent graph. If you draw tangent graph for 0 to pi over 2, right, you'll find it's increasing, no turning point, and there's an asymptote at pi over 2. So if you consider y equal to tangent square x, then it should be still increasing. It should be increasing. And so that's the reason why it should look like this. It should look something like this. Since you consider y-axis and y equal to 3, right? So you should consider tangent square x equal to 3 because you consider the line y equal to 3. So you consider the line y equal to 3. So tangent square x equal to 3. Tangent equals square root 3 because tangent x is positive. Then you solve for x is pi over 3. So that's how you get pi over 3 here. And here is y equal to 3. Here is 3. So to find the area of the region R, right, this region R is bounded by tangent square x, y-axis and y equal to 3, we call it area. So it will be just area of rectangle. Area of rectangle which is with height 3, base is pi over 3. So 3 times pi over 3 minus area under the tangent square curve. So minus integrate from 0 to pi over 3 tangent square x dx. Tangent square cannot be integrated, but we know that tangent square x is just secant square x minus 1. So we change it to secant square x minus 1 and then you can integrate. Integrate secant gives you secant square gives you tangent x. Integrate 1 gives you x. And after that you can work out the area. It's 4 over 3 pi minus square root 3. Next, we look at part 2. Part 2, you are asked to use part 1 and then evaluate integrate 0 to 3 tangent inverse square root y dy. To do that, right, you can check if y is tangent square x, then x will be tangent inverse square root y. And if you look at x from 0 to pi over 3, then y will be from 0 to 3. You can see from the graph. You can see from the graph, right, this is what you should have. It's from 0 to pi over 3. If you consider x from 0 to pi over 3, then y is from 0 to 3. So with that, you'll find that if you integrate 0 to 3 tangent inverse square root y dy, it's just area R. So that's why integrate 0 to 3 tangent inverse square root y dy should be 4 pi minus square root 3. The answer of your part 1. Because if you integrate, you'll be finding this area. If you integrate 0 to 3 tangent inverse square root y dy, you'll be finding area under the red curve about the y-axis, which is just a region area. So it's just 4 pi over 3 minus square root 3, which is the answer to the first part. In part 3, you are asked to show d dx tangent cube x minus 3 tangent x plus 3x. It will give you answer 3 tangent power 4x after simplification. So we just differentiate tangent cube x. Differentiate tangent cube x will give you 3 tangent square x secant square x. Is tangent x then cube. So first it will give you 3 tangent x and square, and differentiate tangent will give you secant square x. So that's how you get this 3 tangent square x secant square x. And then differentiate tangent is secant square. Differentiate 3x is 3. And you can actually factorize out 3. You can factorize out as 3. from these two terms with a minus sign. So plus 3 become minus 1. 3 taken out and minus sign. Secant square x minus 1 is tangent square x. And then tangent square and tangent square, you can take out common factor tangent square. Then you left with secant square minus 1, which you can change it to tangent square again. So it's 3 tangent power 4x. So with that, you can say if you integrate 3 tangent power 4x dx, it must give you back tangent cube x minus 3 tangent x plus 3x. And integrate tangent power 4x dx will be 1/3 of the answer. In part 4, you are asked to find the volume of solid form by rotating r completely about x-axis. So you are rotating r about x-axis. If you find the volume, right, it should be integrate then pi y square dx. Then from 0 to pi over 3, it's pi y square dx, because you rotate about x-axis. If you find pi integrate 0 to pi over 3 y square dx, you are actually taking this region and rotate about x-axis. But the question asks for the volume of solid form by rotating r completely about x-axis, which is actually this region. So that's why you have to consider the rectangle. The rectangle rotate about x-axis minus the area under tangent square graph rotate about x-axis. So that's why first you consider the solid form by rotating y equal 3 about the x-axis from 0 to pi over 3, which will give you a cylinder of radius 3, height 3. Because you just rotate the rectangle about x-axis. So basically you give a cylinder with height. This will be the height pi over 3. The radius is 3. The radius is 3, height pi over 3. The area volume of cylinder is pi r square h. So it's pi 3 square pi over 3 equal 3 pi square. And then you consider the region below the x-axis, below the curve rotate about x-axis, this part, which is integrate pi y square dx, integrate pi y square dx. Y is tangent square x, so y square will be tangent square x square. So this will give you pi integrate 0 to pi over 3 tangent power 4 x dx. Integrate tangent power 4 x dx is 1/3 of tangent cube x minus 3 tangent x plus 3x. That's what I observed earlier. So that's why it's 1/3 tangent cube x minus tangent x plus x. Means sub in x as pi over 3 and 0. After you simplify it, you get pi square over 3, 1/3 pi square. And then you just subtract the two answers. It will give you final answer 8 over 3 pi square.